Okay, the problem is finding the minimum in the rotated sorted array. So what is given? I have given an answer from it's already in ascending order. This should not be in a sequential. It could be one. It could be 1, 5, 6, 9, 12, like this. It, it should not be in ascending order. Sorry, it should not be in a sequential, but it is in ascending order. After that, we rotate it 4 times or 7 times. 7 times means like it is the length of 7, and 7 times rotation gives the original, as you know right now. So after rotation, so whatever it is rotated, after rotation, some unique, like, and also given like in the nums, or like all the elements are the unique elements. In that case, and we have to write an algorithm which will find the minimum one, and in the big of log n time. So what could we say? So we have to find the minimum, okay, and it is already in sorted time, okay, and it is asking for in log n time. So what could be the case? The case would be, it is a, what should we say, binary search. We have to do binary search. Binary search gives a log n time, and it needs a sorted. It's already in some kind of sorted. We'll see it later. It's some kind of sorted. And I think that here, find the minimum, you can do big of in approach, and any length is also 5,000. So it will also pass, but everyone knows this big, this approach. So I'm not going to see this kind of approach. Like, now let's see what could, like, all integers are unique. Now it's sorted but rotated. So what could we do? Like, let's see couple of cases. We'll see couple of cases. After that, we'll write the code. It's a very easy actually. So let's do it. So if you notice there is a pattern, see, it is given a sorted array, right? Earlier it is a sorted array, after that it's rotated. So see this one. So this part, there is two part, now it is becomes two sorted array, like two division, like this part is sorted and this part is sorted, correct? And after that, here if you see, this part is sorted, this part is sorted. Here if you see, this is the actual sorted array. So till the mile, I'll check it, this one is, this is the sorted array, this is the sorted array, like this itself is sorted array. So what do we do in the binary search? In binary search, we start from left and right, our usual case, and check whether until or unless left is, like until a left is less than r, we'll move forward, right? So what do you do? Left and right, correct? So what to do? We find the middle. See here in the middle. So how could you know, like it is not my minimum? So what is the possible cases? So these are the possible cases. Like, these are the one case, like it is already sorted. See, only one item is there. It could be possible, like maximum, like it is very minimum of time sorted. What I am saying, like most of the case, like in the left side, it is maximum number of sorted item is present. Right side, less number of sorted. Here also, in right side, less number of present, and left side, more number of sorted items present. What I actually want to say. Here also, this is a 50-50, like it is a divided equally. So what are the cases? If I find the medium is equal here, and if I check, how could I know it belongs where? It belongs in the maximum number. Like, I need minimum number. So minimum number means every time I have to go to the right side, and in the right side I have to find the minimum number. Right? You can see I can go to the right side. Like I told you earlier, right? Divided the array into two halves. One half is sorted, and second half is also sorted. Right? So entire array is not sorted. But if I consider two halves, that in the two halves, first half is also sorted, second half is also sorted. Here also, first half is sorted, second half is sorted. Here also, you can see this is sorted. So I have to always consider my second half. Okay, see, this is the thing. Like, always in the second half, I will get my minimum number. So in the second half, first element, I will get the minimum number. So anyhow, if I have to check whether I'm belonging to the first half or second half. If I belongs to the first half, okay, my target goal is going back to the second half. So even if I come here, if I belong to first half, my step is going back here. So this case I will talk later. This is a normal case. So this is what we do, correct? If I understand, it is what we do. So now think of it. So what we could do, we'll find a medium. This is my mid. If my medium, it's my mid. What I could do, if I will check is this element. How could I know? Like I belongs to first half or second half. So here, if I stay here, my right is always in the second half. It is for guarantee. I will check whether this medium value is greater or less. Okay. If it is like all element is equal, so I no need to check equal case. I can check less or greater. So if my medium is medium item is actually greater than my right item, that means what? I belongs to the first half. So my target is going to the this side. Okay. So that time if my medium, I can do what? I can assign. This is my L earlier. Okay, let me. Earlier it was my medium. Now I can assign this thing as L. I can do that. If I even now if assume like this is the second yes, here, this is my again medium. If my media earlier what we saw like if it is like medium value is less than my right side. If that is the case, I will do what I can do, like what I said, I can do like assign the left side to that medium. Similarly, if my medium is actually less than, so what does it mean? It means like I am currently right now in the already in second half. If I am in the second half, my right should, like I have to minimize. Now this is my window. So at right now, this is my L, this is my R. So I am already in the second half. Okay. So I have to decrease the window. Like earlier it was here, it was here. So I know it is a second half, so I should have point this here. This is how the binary search work. Sorry, binary search work, correct? So I have to minimize the window. So this is will do as simple as that in binary search. Now like one thing you have to think, like if one thing you have to do, like if this is the case, I can guarantee you, like can I say like if it is a medium, I can say it is greater than my right side. If it is greater than my right side, then what can I say? So is it worthy to put my L here? Then I can do like EL or like whatever the EL or R should point, it should be my valid point, like valid position. That could be my answer. So that means like if I put the EL here, could it be answer like 7? Could it be answer? No, right? It is already present in the what is I called like first half. So anyhow, if it is my last digit, consider this element. Consider this. That's why I take this example L and R. Okay. So it is my mid. This is my mid. So if I point my L, I have to again checking by 9 and 4. Again I'll find that mid here. I'll find my mid here and I'll put what? I'll put L equals to here. So in that case, see, I have I have omitting my actual answer. I'm omitting my actual answer. See this one. Hope you are getting it. See this one. We cannot directly assign this thing to the mid. See this. Let me explain. Okay. So this is my L. This is my R. Correct. And this is my mid. If I assign, like I can see as I earlier told, as I can see, like if is greater than like this item mid value is greater than this, I have to go to the next half. So what I was doing that time, I am assigning this value with L, like new L. This is the new L. If I assign this value with the new L, what is the next range? So next range will become, this is L and R. So what will be the mid next time? Mid next time becomes this one mid. Now what I can see, like this is 1 and this is my 7. Okay. So if that is the case, I have to move what? If that is the case, I'll move R equals to here. I'll move R equals to here. So this mid becomes my R. Mid becomes my R. Now what is the medium? This is the medium. Is it less than R? Yes, so it becomes my R again. What is the mid? Mid is 9. So 9, see, this is now think it. Now my mid is what? Mid is uh, mid is becomes my 9. Okay. So 3 and 4, what will be the mid? 3 plus 4 divided by 2, nothing but 3. So it will be mid. I am doing what? I am assigning AL equals to mid. If this is and right, it is less than my right. So that time I am doing what? AL equals to mid. I am assigning AL equals to mid, right? If that is the case, then my every time will AL will stay in this place. So I cannot do AL equals to mid. I have to do mid plus 1. Mid plus 1. Why I am saying that? See here, first of all, again come back in the first example. I have to do mid plus 1. If I am here and here, mid is what? Here, this is my mid. If I find it out, my current mid item is greater than my right item. That means I'm in the first half, first sorted part. Then I can move my mid. I can move my earlier. I am moving my L in the mid position. So, but if I move in the this position, will it make any problem? No, right? I am current now. This is my first half. This is my first half. So my first half may end at the mid position. Okay, it first half may not end at mid position. This is here. First half is not ending in the mid position. This is here. First half is ending with the mid position. Already, this is the last index of the mid. So these are the two cases. Correct. So if I assign my new L at the mid plus 1, what will happen? If I do the mid plus 1, it what will it will do? It will point to the either it will point to the again 1 plus item like this greater than my current value, but still I am decreasing the size, decreasing the window. So if I do right now, if I do in the item here, if I do mid in this zeroth index in this example, if I point 0 in this position, now L is pointing what? Now L is pointing actually my actual smallest element. The L is pointing actual smallest element. In that case, this is my L, and now I will this is my usually this is my R, earlier it is my R. So I'll do what? L plus R by 2, it will becomes 1, R becomes CR, then L0 and R0, then mid is what? 0. If mid is 0, then R will again comes back and I will reduce and this will be here. But the thing is like, come, this is what we will do. So we are assigning AL equals to mid plus 1, not only mid. Okay, let's see. Can we do like R equals to, I doing what R equals to mid as doing. Can I do R equals to mid minus 1? Can I do that? Let's check. Can I do R equals to mid minus 1? Is there any example? Good example is there, or I missed the example. Let's see. I'm hoping this is the example I have taken. Let's. Otherwise, I'll take another example. So this is L. This is R. This is my mid. So mid equals to what I am doing. Uh, this was is mid, it is less than my R. So right now I am assigning to like what I saw, like I cannot assign mid equal like L equals to mid only. I have to do L equals to mid plus 1. So earlier I was doing R equals to mid as well. If this is the case, my current element is smaller than my right element, mid element is smaller than my right element. I want to do this. Let's do also mid minus 1. So can I do that? So if I do, this is my mid element, so R will be this one. So what will be a mid value? Mid value will be this. Mid value will be this. So right now, if I do R equals to mid minus 1, see what? This is my right now. So this is my right now. So if I do that mid minus 1, R will point directly at the 9. So that time I am again skipping my smallest element. So I cannot do like in the mid could be the smaller only. Mid could be the smaller. So R actually finding the smallest value. Here actually R finding the smallest value. So if I if L is the L is pointing the actually right, that is highest value, R is pointing the smallest value. If R, like if my mid can point any higher and smaller. Okay. So L can move to the, if mid is pointing any higher value, if move is pointing any higher value, the next value of the mid could be higher or lower. So next value of the mid could be higher or lower. If it is higher, like AL is always pointing my higher value, I can move that higher value. Now, if it's pointing to the lower value, so AL will move to the lower value and AL will be saturated in that position. AL will not change after that. R will change and coming here. So what is AL actually doing? From here, AL actually moving lower value to higher value. R is coming to higher, that means uh, higher to lower value. So AL, if I pointing my AL to mid plus 1, if it is a higher value, then AL will again move. It will again move. AL will again move. This is possible. But if AL is pointing to the here in this case, if AL is pointing to the smallest value after one iteration, it will not move. AL will saturate. AL will not become stationary. It will not move. But R will coming from right to left. Similarly, R will coming from right to left. I guess you get it. Like that's why I have to assign R equals to mid only, not mid minus 1. That I have to assign. I guess we're getting this. And for this example, this is pretty easy. Pretty easy. If it is L is point here, L is here, and R is here, mid is this at this position. This is my mid. This is my mid. R will point after that here. After that, what will happen? I'll remove this mid and R. Again, this is my mid. Like one is my mid. R will point mid here again. And after that, what? 0 and 1. Uh, 0 and 1. It will compare and if 0 becomes mid, 0 becomes mid, R will point to the mid again, R will point to the mid. After that, my condition will end when L is less than R. Up to that, I have to do the iteration. If L equals to R, then I will stop the iteration. As simple as that. I guess you get it. This is the what we have to do. So let's say find. Just write the pseudocode. Find. Let's say function find. Function find. What is given? Nums is given. Nums is given. Correct. So nums is given. What I need actually is left and right combination. So left is 0, my 0th index. Right is nothing but my nums of length, nums of length, nums of length minus 1. That is the what. So what I'll do, I'll iterate for until L is less than Y. So while L is less than R, while L is less than R, until the case, I'll do what I have to do, calculate. Obviously, I have to need mid. So mid equals to L plus R divided by 2. Okay. There is another notation is there. You can do this thing. So mid equals to, if you know the bit manipulation, you can write this one as well. L per plus 1. This is how you can also do the division. Okay. So whatever for right now, forget about this. Okay. So mid is that. What I told you, I have to check whether mid is there or not. Like if my my nums of this mid, nums of mid, see what are the two cases. If it is higher or greater, if it is higher, wait, what I told, if nums of mid is greater than nums of what is say R. If it is the maximum value, then it's a fast case. So I'll simply do what? AL equals to mid plus 1. And the other case else, I'm writing else because that is it is saying all elements are unique. There is no point of writing equal symbol. If that is the case, then R equals to mid. R equals to mid. So that is the case. And at the end, I will return uh, nums of R. As I told you, R actually pointing to the smallest element. So it will return R. This is what we have to do. So what is the time complexity? Obviously, it is a binary search, you know. So time complexity is big of log n. What is the space complexity? We're not taking any extra space, right? So it is a big of 1. That's all. This is the smallest. This is the trick actually. The main trick is nothing but this one. This assignation. Assigning the value. L equals to mid plus 1, R equals to mid. This is what you actually do. nothing else. Hope you understand the concept. And as always, if you find any mistake in this video, you please let me know so that I can rectify. And if you find any useful information on this topic, please let me know so I can also learn. Thank you. Bye bye.